Exercise 17b, differentiation. In the last video, I was demonstrating how to find the derivative by first principles, and I could imagine that if we have to find every derivative that way, imagine trying to find a derivative of a quintic of something to the power of 7. That would be very, very tedious. So thankfully, we've come up with a pattern. You might vaguely remember from the last video that we were dealing with something that said 6x cubed, no, it was 2x cubed plus 7. And we found that the derivative is equal to 6x squared. So what is the pattern? Well, the 2x cubed part, if I was just to draw it here, well, you could also get that derivative by bringing that 3 down. You get 3x, and then the cubed, and you get 3 times 2x, and then we take that 3 and we subtract the 1. And that gets you 6x squared. And that's the derivative rule for any powers. But you might be wondering, why does the 7 disappear? Well, what about if I rewrote it slightly? I know that 7 is the same as saying 7 times 1. That makes sense. 7 is the same as 7 times 1. So that could is there another way that I can express the number 1, especially in terms of x? Well, is there any powers that if I'd made x to the power of something, will it be equal to 1? Yes. What if I made that x to the power of 0? Anything to the power of 0 is 1. So therefore, 0 times 7, x, 0, take away 1. Well, 0 times anything is just going to be 0. So this is just going to be 0. And so we get 6x squared. Now, I'm going to have to tell you that that is the correct answer, but my working out's not very good because I've implied that this question is equal to this answer. Well, actually, it's not true. What I would need to say is I would need to say that the f of x is equal to this, and therefore f apostrophe x is equal to this. I know that seems, again, pedantic and pernickety, but it is very important to actually write correct mathematical grammar. Otherwise, what you've written is, in all sense of the words, bollocks, and we can't have that. So here I've got just some shorthand rules to remember. One thing that is very useful, I think, is just making sure you remember that a square root is equal to it's the power of a half. That's very, very useful there. But otherwise, all the others should be, as you can see. So any constant, just a plain ordinary number disappears. If it's just a letter x, that becomes a 1. Why is that? Because if I've got x to the power of 1, the derivative of that is just going to be 1 times x to the 1 minus 1, which is 1 times x to the power of 0, which is equal to 1. Find the derivatives of the following with respect to x. 2x squared plus 4x. So now I'm going to use a different notation because there's no y and because there's no f of x. I'm actually just going to write the derivative or the change with respect to x like this. Put brackets x squared plus 4x is equal to, so the 2 will come down, and then I'll minus 1 from the 2, and then 4x, so that's x to the power of 1. So that's 1 times 4x to the power of 1 take away 1, which will be 2x plus 1 times 4 times x to the power of 0. Anything to the power of 0 is equal to 1. So that's just going to be equal to 4. We've got f of x is equal to 10x to the power of 5 plus 3x to the power of 4. So the derivative is equal to, and I usually like to just put little color codings in here. So this will be 5 times 10x to the power of 5 take away 1 plus 4 times 3 times 3x to the power of 4 take away 1. So that becomes 50x to the power of 4 plus 12x to the power of 3. You don't need to simplify or factorize that. It's at this stage, you just, a final answer like that will be fine. Yikes, I've got this horrible fraction here of 10x to the power of 5 plus 3x to the power of 4 over 2x squared. So before I even begin with this, what I'm going to do is simplify. So when you've got something plus something in the numerator, all over the same denominator, that's essentially the same thing that what I've written down here. So 10 divided by 2 is going to be equal to 5. X to the power of 5 divided by x squared. Need to remember our index laws here. X to the power of 5 divided by x squared is x to the power of 3. 3 over 2 can't simplify. X to the power of 4 divided by x squared makes it x squared. And now we've got a y equals, so we can do a dy dx. And that's going to be 3 times 5x 3 take away 1 plus 2 times 3 over 2 x squared take away 1. And so this becomes 15x squared plus 3x, like that. Because 2 times 3 over 2, the 2's will cancel out. Or you could say 2 times 1.5 would get you 3. Example 2, find the derivative when x is equal to negative 2. So when you see something like this, it's 2 steps. Find the derivative. Then the second step is substitute x for whatever number's inside, in this case negative 2. The rookie mistake a lot of people make is they do the substitution first. Don't do that. Find the derivative first, then do the substitution. So we have our derivative, which is equal to 15x squared minus 3. Where did the y is at minus 3? So don't forget that that's x to the power of 1. The 1 comes down. And 1 take away 1 is 0. X to the power of 0 is equal to 1. So it'd be 1 times 3 times 1. And that's where you get 3. So we get 15 multiplied by negative 2 squared minus 3. So negative 2 squared is equal to 4. So 15 times 4. 15 times 2 is 30. 30 times 2 again is 60. Take away 3. You get 60 take away 3, which is 57. As a final statement, as a reminder, find the derivative first, then substitute. Example 3. Find the gradient of the tangent line to the graph of f at the given point. Hence state the equation of the tangent line. So we've been given an equation of f. We've been given the coordinates at which the tangent line hits the graph. As a reminder from previous, when x equals 1, if this is a tangent line, then the gradient of the tangent line is equal to the gradient of f, or the original function. So we're going to find the derivative. We're going to sub x equals 1. So this will be the m in y equals mx plus c for the tangent line. The tangent line is a straight line that adheres to that rule, the y equals mx plus c. Remember that from chapter 1 and 2? Oh God, that was so long ago. Y equals mx plus c. That's the straight line formula. And solve for c. So let's find the derivative. There's the derivative. Now to sub when x equals 1. So this answer of 2 is going to be the same gradient as the equation of the tangent line. So when I write my equation of my tangent line, m will be equal to 2. So now I just need to find c, which is the y-intercept of the tangent line. So to do this, to find c, we need a set of coordinates, if you remember that from chapter 2. So what else better than the coordinates they've given right for us, or right in front of us? So we substituted x equals 1. That gets us negative 1 is equal to 2 plus c. We minus 2 on both sides, and we get negative 3 is equal to c. Therefore, the equation of the tangent line is y equals 2x minus 3. Find the coordinates on the graph y equals x squared where the gradient is equal to 16. This is almost a reverse of what we did before. This time we've been given a gradient value and now we need to work out those coordinates. So, as is often the way in this topic, if you have no idea what to do, if you're struggling, if you're still not getting it, just find a derivative, because I'm sure that's pretty much what the first step for most of these questions are. So, there's the derivative. We're now going to solve for x when the derivative is equal to negative 16. So when x is equal to negative 8, the gradient of the equation y equals x squared is equal to negative 16. So now we just need to find the other coordinate. And there's the answer, negative 8, 64. Now, one of the most common mistakes I see when people do this question is they forget what they need to do. They know they need to find a derivative and solve for it equaling negative 16 and get this answer here of minus 8. The common mistake is that people will then go, oh, I just need to substitute it back into the gradient. Oh, of course, it's equal to negative 16. The coordinates are equal to negative 8, negative 16. No, don't do that, dear. When we're finding coordinates from the graph, you need to substitute it back into the original equation like I've done there.